Hello, my name is Davis, and through this presentation, I would like to walk you through the DevOps pipeline we created for two applications. The first one was an app called Checkbox, and through this we could host surveys. It was Node.js based and required MongoDB and Nginx. The second was called iTrust, and it is used to keep track of users' medical records. It was Java based and required Maven, SQL, and Tomcat. Now, as our DevOps pipeline, which you see here, consists of a build stage, an analysis and test stage, and finally the deploy to production stage. And towards the end, I would speak about the special milestone which we achieved. In the build stage, we automated the creation of a Jenkins server and assignments of Jenkins jobs to enable the local build of both the apps. Ansible was the config management tool we used, and we also used certain Jenkins plugins. Post-build success, the app is locally deployed to Vagrant VMs. Now, this is a high-level diagram of what I just explained, and this is the Jenkins server, the build log, the Checkbox IO app, and the iTrust app. Now, in the test and analysis stage, consider a developer checking in code and test cases for the code. Now, we created a fuzzer that would fuzz this code and run the test cases against it. If it passes, the test cases don't work, and we created a tool that determines these useless test cases. It was implemented just for the iTrust app. Now, moving on to the analysis component, we analyze the code coverage using the Jenkins Jacoco plugin, and we also put certain constraints for the code, and it could be considered like a code review process where no method should have complexity greater than 3, it should not have more than 120 lines of code, and message chaining should be limited. And so in case these constraints are encountered within the code, the build fails. This is the a snip of the build failing if the constraints fail. This is the useless test case and the fuzzing generator, and this is the code coverage using the Jacoco plugin. Now, in the deploy stage, we automated the deployment to production, that is the EC2 instances. We also created a Nomad cluster and ran a Nomad job on one of the worker nodes. And in case that worker node fails, the job was carried out by other worker nodes. We also implemented feature flag using a Redis master-slave architecture. Now, finally, we did a canary release, that is, certain percent of the traffic is sent to a stable version in production, and the remaining is sent to a version that is not so stable. And this was implemented using load balancer, whose logic depends upon the Redis database, which has IPs of all the instances tagged stable and not stable. Now, finally, we also implemented a rolling update where we did a serial rolling update on all EC2 instances with a newer version of the code. All the tasks that I mentioned till now was automated completely by Ansible Playbook, Bash scripts, and Jenkins plugins. Now, moving on to the final special milestone, I would like to shift the focus now onto the customers who would use our DevOps pipeline to deploy their application to the cloud. But before they do that, they need to be aware of various factors of the app that might inhibit their move to the cloud. These factors would result in the ineffective utilization of resources. They would not see any edge over their competitors and essentially not gain profits. And the final results which we send over to them might help them refactor the application or maybe even choose the right provider. So now, how we are going to do this is basically we analyze various aspects of the app, such as the compute, the network, storage, compliance, security, license, dependencies, and the overall architecture of the app. And based on the customer's answers to the various questions within every aspect, we assign certain scores and classify the application and email a final result to the user. Thank you so much for your time, and we are open for questions.